Okay, you might want to pause the video at this point and read through this problem before I go on. I'm going to skip right down to the bottom because that's typically where the objective function lies. How many types of each car are needed? So we're talking about our variables being two different types of cars. One is the Topaz and the other one is the Mustang. So let's focus on the information that revolves around these two variables. T is going to be the Topaz, and that will be the number of Topaz cars. M is going to be the number of Mustangs. Now that we have our variables set, I want to reemphasize that your constraints and your objective equation will now involve these two variables. So let's find out what we can about them. Let's look for our constraints. Reading on through the problem itself, the plant has a maximum, that's a key word, maximum production capacity of 1,200 cars a week. It doesn't say 600 Topaz and 600 Mustang, it says 1,200 cars. So according to this, the plant doesn't care. They just know that they are going to make some number, let me put this back in black, they're going to make some number of Topaz along with some number of Mustangs, and it is going to max out at 1,200 cars. So they could make 0 Topaz and 1,200 Mustangs, they could make 1,200 Topaz and 0 Mustangs, they could make 600 and 600, they could make 300 and 900. Really doesn't make any difference, but you should have the idea that that will create a line. Now let's go on into the problem, change colors. If during the spring a dealer orders up to, well, that's kind of a key word, orders up to 600 Topaz cars and 800 Mustangs each week. So how do we phrase that? By virtue of the fact that I see the word "and" in here, I'm going to work from the idea that for the dealer, Topaz is, oh, I just circled the wrong thing. I'm sorry. Let me go back. Here we go. Okay. That the dealer orders up to 600 Topaz and 800 Mustangs each. So you might be tempted to write T plus M. And notice I said tempted to. That T plus M is going to be less than or equal to. Well, now what do you put in? Do you put in 600? Do you put in 800? Do you total it and say 1,400? Let's think about that for a second. 1,400. That means that if I leave it like this, then I could say 0 Topaz and 1,400 Mustangs. That would let this equation work. However, if you read this particular sentence again, it won't work. It says up to 600 Topaz and 800 Mustangs each. So I've got this particular inequality set up incorrectly. So let's go back and try again. How about if we don't read this word and we go with our instincts and we say that the number of Topaz up to 600, so T is less than or equal to 600, and Mustangs are up to or equal to 800, or less than or equal to 800. So we now have our constraints. They've got the variables, and now let's see what the graph looks like. So as I'm looking at this problem, I see that I've got something that goes from 1,200, and if you remember, I was basically drawing a table, 0, 1,200. This is this equation, a table for it. 1,200, 0 would work. 800, 400, 600, 600, etc., etc. So what I'm really looking for is I want to build a table that's got 1,200 is kind of a max because it looks like that's about as far as the graph itself will extend. So let's work from that. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I really want 1,200, so we'll make these 200 each. So 200, 400, 6, 8, 10, That would be 1200 right there. And I keep the scale down at the bottom about the same. So 200, 400, 6, 8, 10, and this would be 1200 right there. So at this point, why don't we just snap a line right across? Because I know that my x-axis and my y-axis, I'm going to go ahead and designate this is x, or actually let's call that, let's call this the t. And we've got everything in these variables. That'll be t, and this axis will be m. Not pretty, but I'm hopefully getting my point across. So t and m, and I'll put my ruler across there, and go from 1200 to 1200. Pretty close. Okay, that would be a constraint. And since it's everything under 1200, then I would want to shade over there. But so I can keep the feasible region kind of open, I'm going to X out all the stuff because this region over here is not feasible. Okay, let's put in our other constraints. Our next equation, we've done that one. Our next equation says t has to be less than or equal to 600. Well, the x-axis here, we're going to call that t. And if I'm counting over, that'd be 200, 400, 600. So that's my t. And I am limited, t is less than or equal to. Now, I know that we cannot process any more than that, so this is also not my feasible region. Nothing over on this side of that line will work. Our last one is going to be this m is less than or equal to 800. Those are Mustangs. And this is my y-axis, or m-axis, I guess I could say. So this is 200, 400, 600, 800. So there's that line. And it's everything under 800. So this is my non-feasible region. Nothing over here will work. And so now I'm left with this region. I'm going to put in some of the critical point, or draw in the critical region. It goes there. I know it can't go beyond that because I've got my black lines and black X's around it. And I know that that is 2. Can't have negative cars, so that goes there. And that goes there. So now what I have is I have a critical point here and here, a critical point down here, and a critical point here, and a critical point there. I've got 1, 2, 3, 4, 5 critical points. So now what we need to do is figure out how many types of each car are needed to maximize profit. So let me go through and let's erase some of this. I don't need this table anymore, because now I'm trying to figure out profit. So let's go back to our written word. It says the profit on each type of a profit on a Topaz is 500 and on a Mustang is 800. So let's put that into terms that we understand. Our profit is equal to $500 for every one of those Topaz made. So the number of Topaz is T, so 500 times T. And on a Mustang is 800. 800 times the number of Mustangs made. Add those two together and you'll get profit. So let's plug in some of these numbers. This first coordinate, right here, that coordinate looks like it is 0 on the x-axis, or on the t-axis, and on the m-axis it looks like 800. So what could our profits be if we have 800 T and 0 M? And just to keep things moving along, this particular point, well, this M axis hasn't changed. This is still 800 right there. So I know that, that point is going to have an M value of 800. But in this case, T, using my 200 scale, that's now 400 Topaz and 800 Mustangs. So 400 Topaz and hang on, what have I got? Yep, 800 Mustangs. Looks like we're going to have to break out a calculator on this one. Okay, this point right here, that is on the T scale 600, on the M scale is 600. Let's see, 2, 4, 6, yeah, 600. So 600, 600. And then looking at this last point right there on the T scale, that is 600 Topaz and 0 Mustangs. So 600 and 0. So now we can start figuring out some of our profits. Anywhere I've got 0, that's, hang on, I've done something wrong now that I'm looking at this. Ah, my last point. There we go. I messed that up. Okay, let's go back and do that one again. No, I did it right over here. It's 600, 0. No, I didn't do it right. Which one did I mess up? That one's 0, 800. Ah, it was all the way back at the very beginning. So I was looking at that thinking, there's no way going all the way around. Let's go back to here. That's not 0. Yes, it is. That is 0. 0 and 800, but I put 0 for Topaz and 800. My pen's freaking out. 0 and 800. You know, I've made one mistake. I better check them all. This one is going out the T-axis. 1, 2, and they're in scales of 200. So that would be on the scale 2. That would be 2 times 200 or 400. 400 out the Topaz. That's correct. And then 800 over here. So that's correct. That would be 800 Mustangs. So that works. Over here I've got 600 and 600. Since they're the same, I can't mess that up. And then down here at the bottom, this last point, that's 600 Topaz. So 600 Topaz and 0 Mustangs. Now it looks better because now I've got a 0 in that column and a 0 in that column. Okay, now let's figure out our profits. So with 0 for T, that becomes nothing. So 800 times 800, well, 8 times 800 would be 6,400. And then I'm multiplying that times 100. Well, that's just multiplying 10 times 10. So 6,400 times 10 would be 64,000. 64,000 times another 10 would be 640,000. The M with the strike is 1,000. This next one, profits there are 400 times 500. Well, that's 200,000. 400 times 500? Yeah, 4 times 500, that's 2,000, 20,000. Yeah, and then the 800 hasn't changed, so that's 640,000 added to that. So this profit number is going to be much larger. That's going to be 840,000 for that one. Let's look down at this. 600 times 500, that's 300,000. We'll just assume thousands. And then 600 times 800, let's see, that's going to be, 6 times 8 is 48, so that's going to be 780,000. And then this last equation should be pretty obvious. We've got the same number of Topaz, but 0 Mustangs. I'll go ahead and complete the math. That's just 300,000. So the largest combination is going to be right here, $840,000, and that is if we sell 400 Topaz and 800 Mustangs. Now, if you're smart, you'll go back through and check and make sure that 400 Topaz and 800 Mustangs are possible. We can go back to the original problem. Maximum production capacity by the plant is 1,200 a week. That works for this combination, 800 and 400. The dealer order is up to 600 Topaz. Well, 400 meets that. That's up to, so it must be less. And 800 Mustangs, so we hit the maximum on that, and we've maximized our profit. So we're done.